Hi, we're looking at the 2017 AP Statistics exam. This was problem 3 from the pre-response section. I have another video dedicated to this, but in this particular video, I'm going to do the same problem, but in a different way. I'm going to use something called a tree diagram, which might make parts B and C a little easier to see. All right, part A is very straightforward. We know that there is this distributor J, and J is normal with a mean of 133 and a standard deviation of 5. So like I mentioned in the other video, you want to write it this way. J is approximately normal with a mean of 133 and a standard deviation of 5. And in part A, they're just asking what's the probability that a melon from distributor J would be greater than 137. So the probability that J is greater than 137, well, if we were to draw a picture of that, it looks something like this. We put the mean of 133 in the middle. We then know that 137 is out here somewhere. And since we want greater than 137, we shade to the right. We just want to get this area in this region. I would recommend using a TI-84. Go to second distributions, which is a button on the front of your calculator that says VARs, do second distributions. Go to number 2, which is normal CDF. You want to do normal CDF. It's going to ask for a lower. In this case, the lower bound is 137. It's going to ask for an upper, which is going to be some large number because we're going all the way out to the right here with this area, going really far out to the right. The mean is 133 and the standard deviation is 5. If you hit enter, you're going to get 0.2119. So that's the probability that distributor J gives a melon that's greater than 137 millimeters in diameter. Okay. Then we have part 2 of the question in a sense. I marked this diagram up a little bit, so let's go to a new page here and paste this in. There's this other distributor K, this other company K, and the probability of their melons be bigger than 137. Oop, it's a little bit, I crossed out something underneath it. Bear with me. There we go. Probability that the melons they make are greater than 137 millimeters is 0.84. So I'm going to write that. I'm going to say probability K is greater than 137 equals 0.8413. Okay, so here's where I'm going to deviate from how I did the problem in my other video. So it says right here, for all the melons in the grocery store, 70% are from J and 30% are from K. So since you have 2 distributors providing these fruits, I am going to make a tree diagram out of this. Let's remember, J is 70% and K is 30%. So I'm going to start my tree diagram by saying, here's J and here's K. And just in case we forgot, 70% are from J. You can see that in this sentence right here. 70% are from J. So on the J branch, I'm going to put a 0.7. On the K branch is a 0.3. Now, the problem seems to be concerned with whether or not the melons are being produced have a diameter greater than 137 millimeters. And you notice that's what part B is asking. So if we look there, let's highlight this. Part B is saying, what's the probability that a melon picked from this store has a diameter greater than 137? And so what you need to realize is that if you want to have a diameter greater than 137, then that melon could have come from distributor J or distributor K. So maybe greater than 137, maybe less than or equal to 137. That can happen from distributor J. And the same thing can happen from distributor K. They might provide you with a melon with the diameter greater than 137 millimeters or less than or equal to 137 millimeters. And we did a whole bunch of work, so we actually know the probabilities that go on these blue branches. So we just go back to part A for a moment. In part A, we wanted the probability that J was greater than 137, and we did all the work, and we got this 0.2119. So that's for distributor J. So I can go up here, and I can put a 0.2119 here. In the problem, they stated for us, let's get my highlighter back for a minute, let's change the colors, that there's a probability of 0.8413 from distributor K that'll be greater than 137. So that gives us a number to put on this other part of our diagram. This is 0.8413. And if we want to, we can find those lower branches. So on the top, we could do 1 minus 0.2119. This becomes 0.7881. On the bottom, we can do 1 minus 0.8413, and we'll get 0.1587. So this turns out to be a really handy way to do the problem, because part B of the question is saying, for a melon selected at random, look at the green highlighting here. For a melon selected at random from the grocery store, what's the probability a melon will have a diameter greater than 137? So we can actually see that in the tree diagram. So let's use my green highlighter. Here's one batch that are big enough, and here's another batch. So to get the probability that we want, we just need to add those two cases together. So the probability that we get something bigger than 137 is equal to 0.7 times 0.2119 plus 0.3 times 0.8413. And if you do that correctly, you get 0.40072. Okay, so I don't know. If you look at my other video, see how I solved it there. Ultimately, in the other video, all I did was write this thing, but not draw the tree diagram. I think the tree diagram helps you see things maybe a little bit better. That would be up to you, I guess. All right, let's look at part C. Let's go back to the highlighter for a minute. Let's pick another color. So I'm going to highlight in purple. Given the melon selected from grocery store has a diameter greater than 137, what is the probability that the melon would be from distributor J? So you need to recognize that as a conditional probability. And so how do we state this probability? We want to know what's the probability a melon came from distributor J, given we know it had a diameter greater than 137. So this is another time where the tree diagram can be pretty helpful. So let's go to back to that page, and the probability J given 137 equals the probability of J and 137 divided by the probability of greater than 137. So just in case you're wondering, this thing I just drew here, this is a conditional probability formula that is common to all the basic probability classes. There's videos about why that works. Okay, so here we are. If we look at the picture, we can see, let's use my highlighter again. Here we go, and let's use the purple. Here are the melons that came from distributor J and are bigger than 137. So that means that the numerator of our fraction here is 0.7 times 0.2119, and we're going to divide it by the probability of a melon being bigger than 137 on the bottom, but we already found that earlier, and that turns out to be 0.40072. So if you just take a minute and type this into your calculator, you multiply the tops and then divide, you'll get about 0.3702, which is the answer to the question. Okay, thanks for watching.